the last video, we talked about how to perform t-test using Excel. And what we did was t-test for two samples assuming unequal variance. We were trying to solve for the first question, which was if the monthly income is impacted by overtime an employee does. And we took a sample data that consisted of following variables: monthly income, overtime worked or not, business travel, and there were three levels for business travel: attrition, that had two levels, whether the person attrited or if he was still with the organization. If you have not watched that video, please go to YouTube and watch that to see how we solved this question. In this video, we will proceed to our next question, which is if monthly income is impacted by the business travel. Let me show you the data set that we used. This is the data set that we used to solve the first question. We are going to use the same data set to solve our second question. And the question is if the monthly income is determined or is impacted by business travel. There are three levels in business travel: non travel, travel frequently, and travel rarely. What we are going to do here is organize the data set, organize monthly income by these three levels. And if you would like to do it on your own, you can just apply filter, click on non travel, copy it or copy all of the monthly income in the non-travel category. You can again choose the correct selection and copy it over to travel frequently or travel rarely. Let us first write the hypothesis for this and see what kind of test we can do to solve this particular problem. So here, if the monthly income is impacted by business travel, the null hypothesis in this case will be population average monthly income of employees who travel frequently is equal to population average monthly income of employees who travel rarely is equal to population average monthly income of employees who do not travel. And why is it that we have taken three groups? Because in travel frequently, we have three groups, right? Three groups: for those people who travel frequently, for those people who travel rarely, and for those people who do not travel. So here we are not dealing with two samples, we're dealing with three different samples, three different groups. Our alternate hypothesis in this case would be population average monthly income of at least one group is not equal. At least one group. It may mean that population average monthly income of employees who travel frequently is equal to population average monthly income of employees who travel rarely, but it is not equal to population average monthly income of employees who do not travel. It can turn any of the equality in non-equality as per alternate hypothesis because it says that population average monthly income of at least one group is not equal. As shared earlier, we have three levels: travel frequently, travel rarely, and non travel. In this case, where we deal with three samples, we're moving ahead from two samples to three samples. The type of test that we will do would be Anova single factor. And again, we will base our decision on the value of P, on the probability value. We will compare this value with our hypothesized P, which is 0.05, hypothesized alpha rather, which is 0.05, which is the risk that we take when we do any of the statistical tests. So let us see how we do that in Excel. Moving back to Excel, this is the data set for the three groups: non-travel, travel frequently, and travel rarely. We'll again go ahead and click on data analysis. This time we are going to do Anova single factor. We'll hit OK. Input range would be the three columns. So I'm going to select all the data for these three columns. Of course, I have the data grouped by columns. I have labels in the first row. My alpha is 0.05. I want my output in the new worksheet ply. So I just checked all of this and I'll click on OK now. It will generate the result of ANOVA. Let us try to consider the p-value, compare it with our established alpha. The alpha or the risk is 0.05. We will compare this p-value with our alpha of 0.05, and here because our p-value is higher than 0.05, if p is high, null will fly, right? That was the rule. So if p is high, null will fly. What it means is if p-value is high, which is high in our case, we will fail to reject the null hypothesis. Fail to reject the null hypothesis. We cannot reject the null hypothesis. Null hypothesis will stay. So, what is our null hypothesis? Our null hypothesis is that population average monthly income of employee who travel frequently is equal to population average monthly income of employee who travel rarely is equal to population average monthly income of employee who do not travel. So, I can say confidently that even if there is a slight deviation in the average of individual groups basis the sample that we have taken, when we talk about population, there is no evidence to suggest that monthly income depends upon these three groups of business travel. So we can say there is no evidence to prove that population monthly income of the three groups differ. This is going to be our recommendation to the organization. Well, as I said, that we are taking a risk of 5%. For 95% of the times, your recommendation will stay even if someone else would take another sample. There would be only 5% chance that your recommendation will go otherwise. Now let us also try to understand some of the numbers that's there. If we have done ANOVA, that's fantastic. These numbers are pretty easy to understand. The count, as our name suggests, it's the count of number of observations in these three groups, and we have taken equal number of observations here. You can take unequal number of observations, that's absolutely fine. Sum is the total sum of monthly income for non-travel, travel frequently, and travel rarely. Average is the simple average, and variance is the variance within each of these groups. What you see here is the result of ANOVA, basis which the p-value has been determined. This p-value is in relation to the F statistic that has come here, which is 0.52. When we convert this F statistic value to equivalent p-value, it comes to 0.58. Now, how it is done, the math behind it, or the F table that we can refer to, I'm not going to cover in this session. But I'll definitely share how you get this F statistic value. This F statistic value is a ratio between the group variance, ratio of between the group variance to within the group variance. So if you have 10785801.66 divided by 20402915.29, you'll exactly get this number. The F critical value is the critical value at this particular alpha, 0.05 alpha. And if you go through the route of comparison of the F statistics and F value to reject or fail to reject the null hypothesis, then you can literally compare these two numbers. But because we are focusing on giving our recommendations basis the p-value, this is the value that we are going to look at to infer about the or to recommend to the organization for the question that was asked. And you can literally do that for any of the question. You literally do not have to go and check each of these scores. You can only focus on the p-value. That is how we recommend for the most statistical questions. And p-value is consistently used across the organization. Degree of freedom and the sum of square importance is to calculate the mean sum of square, which if divided, right, gives you the F value. So sum of square within the group is the overall variance within these three groups. Within non-traveler group or travel frequently group or travel rarely group. What is the total variance? Between means Between non-traveler and travel frequently, what is the variance? Between travel frequently and travel rarely, how much is the variance? Within the group talks about individually in this particular group, what is the spread? When you divide this by degree of freedom, you get mean sum of square. So if you divide 21571603 by 2, you'll exactly get this number. Similarly, you can do that for within the groups. And once you divide this by this, you get the F statistics value, which is compared to F critical value to reject or fail to reject the null hypothesis. These are just some of the numbers that I shared, but even if you do not know the nitty-gritties of these numbers, you can safely recommend basis the p-value. So in this case, our recommendation to the organization will be that there is no evidence to prove that population monthly income of the three groups differ. This is what we are going to info. We will again connect to talk about the third question in our next video, which will be focusing on understanding if attrition increases because of low monthly income. So this is what we're going to talk about in our next video. Till then, stay tuned.